The wave equation shows the mathematical relationship between wave speed, frequency, and wavelength. Velocity is equal to frequency multiplied by wavelength. Velocity is wave speed in meters per second. Frequency is measured in hertz. Wavelength is measured in meters. This equation applies to all types of waves, including sound waves, water waves, and electromagnetic waves. If the wave is traveling through the same medium, its speed remains constant. In this case, frequency and wavelength must adjust to maintain the relationship. If the frequency increases while the speed stays the same, the wavelength must decrease. This means the waves become more closely spaced. For example, if a sound source produces a higher pitch in air, the frequency increases and the wavelength becomes shorter because the speed of sound in air is essentially constant under the same conditions. Similarly, if the wavelength increases while the speed remains constant, the frequency must decrease. The waves become more spread out and fewer cycles pass a point each second. This inverse relationship between frequency and wavelength is a direct consequence of the wave equation. It allows scientists to calculate one quantity if the other two are known, and it helps explain how changes in frequency affect the spacing of waves without changing their speed in a given medium.